Okay, so 1.8 times 10 to the 8th over 1.2 times 10 to the minus 8. Yeah. Okay, give it a try. So let me suggest, just divide the numbers, 1.8 divided by 1.2 on your calculator. So just divide the numbers straight in your calculator. I think you get 1.5. Yeah, I know you do. 1.5. So if you just divide those on the calculator, you get 1.5. And now figure out what to do with the 10 to the 8 stuff. See if you can figure out what to do with the 10 to the 8 stuff. All right, so the answer is going to be 1.5. I divided the numbers. And the decimal is, by the way, automatically in the right place. That's nice. I don't have to do any fiddling with it, right? Now, what do you do with this? Yeah, you can just subtract exponents, right? The 8 on the top minus the minus 8 on the bottom will be 10 to the 16. Or, if that bugs you, you could just say, look, just grab this guy and let him jump up. He'll be 10 to the positive 8, and 8 and 8 is 16. Either way, same answer. Does that make sense? 1.5 times 10 to the 16th? Questions on that one? So what do? We divided the numbers in the front, put the powers together. Negative power jumped up, and then the power became positive. And then these were side by side, so that 8 and 8 added, right?
So for the division problem, the exponent subtract?
There's two ways you could do it. There's actually two different rules that'll work. So yes, when things are vertical, you can just subtract. Like, remember how we had w to the 7th over w to the 3rd yesterday? We'd say that's w to the 4th. Remember we subtracted when they're vertical? So you can do the same thing here, but you got to be careful. It's the top 8 minus the bottom, which is negative 8. It's not 8 minus 8, it's 8 minus negative 8, huh? And so that double negative adds to be 16. Or you could just let the negative powers jump, then it'll become positive 8, and then they're side by side, and you can add them. I'm saying either rule will work. Good, all right. So 8.4 times 10 to the minus 7 over 4.2 times 10 to the 16th. Okay, try that. So same kind of thing. Divide the numbers in the front on your calculator. Or just top of your head. Can you tell? What's 8.4 divided by 4.2? It's just 2, right? And then figure out what to do with the powers. So divide the numbers, that's 2 times, now what do you do with the 10 stuff? There's a couple ways you go. You could take the top power minus the bottom and say that's 10 to the minus 23. It's probably the easiest thing to do. Let's do that. Top minus bottom. Is that good? I'll just do that. We're done. Good. Now move on from there. And oh, by the way, it is in scientific notation. Where's the decimal? It's 2.0. If you want, you can write it 2.0. Whoops. Getting scribbly here. 2.0, it's the same thing. Right? 2 is 2.0. Same thing. All right, the mass of Jupiter is that. And the mass of the sun is that. About how many times the mass of Jupiter is the mass of the sun? That's a weird question. How many times bigger is the sun than Jupiter? Well, how do I do that? What am I supposed to do? What's that? Divide? What makes you say divide? How many times? What do you guys think? Is that right? She's always been right so far. It'd be a safe bet to go with her answer. Experience has proven any reliable indicator, right? Yeah, that's right. That's the right answer. But I wonder if you all feel it. And I mean the word feel, not just some other thing. You want to feel math. You have math feelings. You do. It's just how in tune you are with your math feelings or not in tune. Let me help. I used to read word problems. You know, that was my life when I was in college. I did a bunch of math, science, engineering kind of classes, and so there was billions of word problems, not billions, but thousands of word problems. And so, and I would often not understand them, lots of them. I would read them and go, what in the world am I supposed to do with this? How many times? What do you want me to do here? What I learned, one of the things that really proved helpful to me is if I would take their weird phrases in a physics class or chemistry or whatever, and I would put in normal numbers. I would go, how many times? What are you supposed to do with that? And I would go, 10. I would just pick up simple numbers like this. 10 is how many times bigger than 5? Right? Because that's what they're saying. How many times bigger? And I would think, so if I just put in a 10 and a 5, and somebody said to me, hey, 10 is how many times bigger than 5? I would go, well, 2. Right away. I know that one, 2. And then I would think, okay, what am I doing with the 10 and the 5? Am I subtracting them? No, that wouldn't be 2. What am I doing with the 10 and the 5 to get the answer 2? Oh, I'm dividing. So then I go, oh, how many times is a fancy way to say you got to divide those numbers. I would think way better with simple numbers like this. But the words, I understand the words now. And then I go, oh, you guys want me to divide those numbers. Right. See how I came to that thought with simple numbers? We think better with just nice, easy, simple numbers. Okay. So they want you to divide. It's a big fancy talk, blah, blah, blah. Divide these numbers, please. Okay, we will. So how do we divide them? Put the bigger one on the top, the sun, 1.998 times 10 to the 27th. Over the smaller one, Jupiter, little bitty tiny Jupiter, times 10 to the 24th. You want me to divide? That's how you find out how many times bigger something is. You divide. So, okay, can you do that thing? So you know what to do, right? Just like the other ones we did. Divide these on your calculator. This would be calculator. 1.998 divided by 1.900. Do we got an answer? What's 1.998 divided by 1.90? It's going to be 1 point something, I think. Yeah, how many do they want? They want thousandth. They're saying round to the nearest thousandth. Where's the thousands? 1,000 has how many zeros? 3, so it's the third place. Third place, Pastor says. Now remember how rounding works? You circle the place you're supposed to stop in. Thousands, third place. Look 1 to the right. If the 1 to the right is 5 or more, you go up, huh? So it's going to be 1.052. Does that make sense? Times 10 to what power? What do these powers do? Subtract 3. Done. Is that good? They want, it says right here, use scientific notation. They want a scientific notation answer. Oh, I should mention, when you enter these answers into Math Excel, you have to use a special symbol. You guys doing that in your homework right now? Did you see that special symbol they need? Let me show you. Everybody got this one down okay? That all good?